Today in this session, we are covering the structure, introduction and declaration. So these are the outlines of this session: introduction, then declaration, initialization and accessing structure members. Structures. Structures are a collection of one or more variable, typically of different type, grouped together under a single name for convenient handling. And in C, the keyword struct is used to define the structure. So first we will try to understand that why the structure is needed. So suppose you have a record of the mixture of variables, for example, the name, your roll number, your marks and all. So name will be a collection of characters, that is a string. Roll number might be a number, that is integer, and marks that can be a float, like 2.5, 80.5 or 98.2, like that. So we cannot use the array for this purpose. Why we cannot use? Because when we have the array, so array can store only a single type of data in it. But when this kind of a requirement is there, where we have the record and each record contains the different type of data type elements, then we need to have a structure. So here I am outlining some basic difference in array and structure. So a structure may contain variable of many different data type, in contrast to array that contain only element of the same data type. Structure are commonly used to define record to be stored in file. So this is a general application of the structure, that what we do is we make a structure that is nothing but it's a record, and then we store that record in a file. So pointer and a structure facilitate the formation of more complex data structure such as linked list, queue, stack and trees. So when we need this kind of a data structure like linked list or queue or stack or tree, then we need to have a structure, and we also need to have a pointer also, so that we can point to the next structure. Structure definition. Structures are derived data type. They are constructed using object of other type. Let's see the example. Consider the following structure definition: struct card, opening braces, curly braces, char star face, char star suit, closing braces, and semicolon. So keyword struct introduces the structure definition. The identifier card is the structure tag which names the structure definition and is used with the keyword struct to declare variable of structure type. So I'm talking about this actually, the card. So card is your structure tag and which is used with the keyword struct, right? In this example, the struct type is struct card. You can see here at the bottom, this one, right? Variable declared within the braces of the structure definition are the structure members. So this struct face and char face and char suit, both are of pointer type. So both of them are called the structure members. So this structure has the two members, one is face and other one is suit. The member of the same structure type must have unique name, but two different structure type may contain the member of the same name without conflict, right? So what we want to tell you here is that if you have the two members of same type, that is character pointer, and this one is also character pointer, then their name must be different, right? Each structure definition must end with semicolon. So always remember that at the end of the structure you always put this semicolon over there, right? Now, the definition of a structure struct card contains member, face, and suit of type char star. The structure member can be variable of primitive data type, example float, int, etc., or aggregates such as array and other structures. A structure member can be of many types. For example, the following struct contains character array member for an employee first and last name, and int member for employee age, char member that would contain M or F for the employee's gender, and double member for employee hourly salary. So you can see this structure. So you have a struct employee, then you have these are the members. So first one is char first name, and which has the limit of 20. So the first member is the array, the name of the array is first name. Second one member is again array, that is the last name, and that is also an array, and the int age, and char gender, which will be either male or female, and double hourly salary. And we have ended this particular structure using the semicolon. A structure cannot contain an instance of itself, right? So we will see this in this example. For example, a variable of type struct employee cannot be declared in the definition for struct employee. So a pointer to a structure employee, however, may be included. So it says the two things. The first thing it says that you cannot declare or a structure cannot contains its instance inside it. And second, it says, but you can have a pointer variable of that particular struct type. So I will try to explain you what does that mean. See, if you see this particular structure, so this structure is struct employee 2, right? And in this struct employee 2, what I am trying to do is I am trying to create an instance. So how you will create the instance? So you write struct, then structure name, and then a variable, right, person. So I am trying to create an instance of struct employee 2, and I want to name it as person. But if you will do this inside the same structure, then it will give an error. But what we can do is we can have a pointer of type struct employee 2. It means there is a field inside the struct employee 2, or there is a member inside the struct employee 2 which can store the address of the similar kind of a structure. So this is actually used when you declare the when you use the linked list, when you use the queue, when you use the tree, then this kind of a declaration is required over there. So just you have to understand that this instance is not allowed, right? But a pointer variable is allowed. The struct employee 2 contains an instance of itself person, which is an error. So as I told you that EPTR is a pointer which can store the address of the similar structure. So we can it is permitted in the definition. A structure containing a member that is pointer to the same structure type referred to as self referential structure. So self-referential structure are used to build linked list data structure, as I told you in the last slide. Structure definition do not reserve any space in memory. Rather, each definition create a new data type that is used to define variable. Structure variable are defined like variable of other type. The definition struct card, a card, DAC, star card, pointer. Declare a card to be a variable of type struct card. Declares DAC to be an array with 52 element of struct card, and declare card PTR to be a pointer to struct card. So this is how we do the definition of structure. Variable of a given structure type may be declared by placing a comma separated list of the variable name between the closing braces of the structure definition and the semicolon that end the structure definition. For example, the preceding definition could have been incorporated into the structure card structure definition as follows. So what we want to do tell you here is that structure definition can be written at the end like this. So when you are defining the structure struct card, char star face, char star suit, at the same time what you can do is, so in spite of writing a separate line for the definition of the structure of this type, when we do the declaration, so a card means a card is a instance of this particular structure. DAC 25 is a instance 52 instance of this type of structure. A card PTR is a pointer of this type of structure. The structure tag name is optional. If a structure definition does not contain a structure tag name, variable of the structure type may be declared only in the structure definition, not in the separate declaration. The valid operations that may be performed on a structure are: the first one, assigning a structure variable to a structure variable of the same type. Second is taking the address of an structure variable. Third is assessing the member of a structure variable and using the size of operator to determine the size of structure variable. So these are the four valid operations on the structures. Structure may not be compared using the operator equal to and not equal to, because structure members are not necessarily stored in consecutive byte of memory. So when you use the structure in your program, you cannot use the equal to for comparison or not equal to for comparison, right? So sometimes there are hole in the structure. Hole in the structure means the two members may not be consecutively in the memory, because computer may store a specific data type only on certain memory boundaries, such as half word, double word boundaries. A point to remember, and try to understand the difference between the definition and the declaration. So what happens when we define a structure? So how we define the structure? So we just write a struct and then name for that structure, and then all the members inside that, and it should be end with a semicolon. So what happens when you do the definition? Definition only tells you that there is a structure with the name, say let's say employee 2, and this is just like as it is predefined that what will be the properties of integer, what will be the property of floating point and all. So the same way we have defined the structure here. Second part is the structure declaration. So in the declaration part, we say that we are now going to allocate the memory for this particular structure. So when you write struct card, a card, right? So then here what you are going to do is you are going to allocate a memory a card for struct card type. You are going to allocate the memory for DAC52, and this is an array of a structure. So there are 52 reserved space of size struct card, and you are going to have a pointer type variable, that is card PTR, for struct card. So this is what we do in the declaration. See, this is similar as we do in the for our primary data type, that is for integer and floating point. So in place of integer, what we have written here is struct card. So in integer, what we do is we write int, and then suppose you write a, then you write b array of 52, and then star c. So what happened in that? That all that becomes the integer type, right? Here, but here we are declaring it for structure type. Structure initialization. Structure can be initialized using initializer list as with array. To initialize a structure, follow the variable name in the definition with a equal sign like this, and a braces enclosed, this opening curly braces and closing curly braces, comma separated list of initializers. So these are the two initializers. So if you see the definition of the struct card, then we have the two members in that. The first one is char star face, and second one is char star suit, right? So these are the two. So as it is covered in the pointers, that a pointer character can be used as string. So we are making the use of that. So face, the initial value of the face will be equal to 3, and initial value of suit will be equal to hertz. So create a variable a card to be of type struct card, and initialize member face to 3 and members suit to hertz. So this is how we do the initialization. If there are fewer initializers in the list than member in the structure, the remaining members are automatically initialized to 0 or null if the member is a pointer, right? So what we want to say here is that if you give the less number of members than the actual you have for a structure, then what will we do? The remaining member will be initialized with the value 0, and if the member is of type pointer, then it will be initialized with the null. A structure variable defined outside a function definition are initialized to 0 or null if they are not explicitly initialized in the external definition, right? A structure variable may be also be initialized in assignment statement by assigning a structure variable of same type, or by assigning value to the individual member of the structure. So this is how the initialization can. Now accessing structure members. So now the question comes that how we can access the member of a particular structure. So there are two ways to do that. The two operator are used to access member of a structure. The first one is the structure member operator dot, also called as the dot operator, and the structure pointer operator, that is arrow, also called as the array operator. So you can use either dot or you can use the arrow operator to access the member of a particular structure. The structure member operator access a structure member via the structure variable name. For example, to print member suit of a structure variable a card, use the statement this. So you have the structure struct card and it has the two field face and suit. So suppose you have declared a structure variable a card, right? So if you want to access the value of a card in the a card, if you want to access the member variable suit value, so what you can do is you can simply use a card dot suit, right? So this is how it will display it. And so whatever the value are, so in the previous example we have assigned the value of suit is equal to hertz, so the hertz will display here. The structure pointer operator consists of a minus sign and a greater than sign with no intervening space. Access a structure member via a pointer to the structure. Assume that the pointer card PTR has been declared to point to a structure card and that the address of the structure a card has been assigned to card PTR. So to print member suit of a structure a card with pointer card PTR, use the statement this. So if you have declared a card PTR, right, that is of type struct card, then you can use the arrow operator to find the value of the suit. The expression card PTR arrow suit is equivalent to star card PTR dot suit, which dereference the pointer and access the member suit using the structure member operator, right? The parentheses are needed here because the structure member operator dot has a higher precedence than the pointer dereferring operator star. The structure pointer operator and the structure member operator along with parentheses for calling function and braces, array braces used for array subscripts having the highest operator precedence and associate from left to right. Now let's try to understand the both the way of accessing the structure members with the help of this program. So in this program, you come to the line number 4 directly. So hash include stdio.h. After that, what we have done is we have given the definition for a struct card. So the first member is star face and star suit. Means face is a string kind of a uh, member, that is a pointer of character, and suit is also a string that is pointer of character. So and this is the semicolon, so this structure ends over here. So int main void. So now what we have done is we have declared the, or we have declared the two variable, the a card and card PTR, right? So a card is a normal structure card variable. This is the declaration of the a card, right? And the second one is the card pointer. So card pointer is a special kind of a variable which can store the address of struct card type structure, right? So first one is the normal variable and the second one is your pointer variable, right? So now coming to the assigning the value. So what we have done is in the a card we have assigned the value face, uh, that is ace, and in the a card for suit we have assigned the value spades, right? And then after that what we have done is we have stored the address of this particular uh, structure variable in the card PTR, right? So how we have done the address of a card. So a card is a normal structure variable, and with this special operator we will find the address of this particular structure, and then that value is copied into the card pointer, right? So the card pointer is now pointing the structure a card. So now here I will tell you that how we can use the dot operator or how we can use the arrow operator. So in which case we use the dot operator and in which case we use the arrow operator. So these are the things which we have used here: percent s, percent s, percent s, and then slash n, percent s, percent s, percent s, then slash and again percentage, 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 then slash again. So in the first percentage, what value will go? That value will go which is stored in the a card dot face. So a card dot face, the value is ace, right? So ace will be printed as it is, then second as off will be printed, and third one is a card dot suit. So a card dot suit, the value is spades, so spades will be printed, right? So then after that, what we have done is we have printed cards ptr arrow face. So card ptr is a uh, pointer which points to the structure type variable, and which structure type variable it is pointing right now? It is pointing to the a card. So card pointer arrow face means whatever the value you have in the card face, a card face, that value will be printed. The only difference here is when you have declared it as a using it with the help of pointer, then you are using the array arrow operator, and when you are accessing with the help of normal variable, then you are using the dot. So card pointer arrow face will also print the ace value, right? And off will be printed as it is, and card pointer suit will point the spades, where what are the values stored there in the suit. And a card pointer is pointing to the card pointer is pointing to the a card. So in the a card suit you have the value spades, right? So that's why this is how it goes. So the moral here is that when you want to access a member of a structure with the help of a pointer variable, then you will be using the arrow operator, right? Array operator. If you want to access the member of a structure and through a normal variable of the structure, then you are going to use the dot operator. So these are the two different ways to access the member of a particular structure. So either you can use the pointer variable or you can use the normal variable, right? So in normal variable use dot, a point through with the help of pointer variable, then use the arrow for that. That's it. So this is my mail ID. Thank you very much.